Hello, Dr. Young.
Hello.
What are we looking at in statistics this week?
Well, according to the S1 textbook, we're up to chapter 9, which is the normal distribution.
Oh, the normal distribution.
Yeah.
Okay, so we know that the normal distribution kind of looks like this.
Yeah, that's a bit of a coincidence, isn't it?
What a great drawing.
Yeah.
And there's lots of things in the world that look normally distributed, like, I don't know, like the heights. If we took the heights of the entire population,
Okay.
well, we'd expect them to be distributed a bit like this, in that, you know, there'd be some really tall, freakishly tall people, but not very many, up at the top end.
Right, so I guess this would be some really short people.
Yeah.
Again, not very many.
In fact, most people would be around the middle height, or the mean height.
Okay.
So they'd be roughly in the middle.
So there's more of them.
Yeah.
Okay. I wonder, do you think the heights of the people in the maths department would be normally distributed? So the shape would be like that?
Oh, yeah. I do wonder if we're all normal.
Normal? I'm normal. Yeah?
Mr. Newton? Anyway, well, if we're looking in statistics, we want to link the normal distribution up with probabilities.
Okay.
So we need to link it, well, there has to be some sort of connection. And what do we know that probabilities all sum to?
Never sure about this one. I think I might just ask Mr. Newton. Mr. Newton?
Mr. Newton?
Mr. Newton?
I think you have to give it your best guess, Doc.
Well, we're never in any doubt, I go for 1. So 1.
Yeah, the probabilities all sum to 1. And the way that links here is the area in the standard normal distribution, the prototype, the stereotype, the every other type, the area under the graph in the archetype is 1.
Okay.
So the area under this graph sums to 1.
Okay.
Now, in this mother type, normal distribution, the
Yeah.
standard normal, the mean is 0.
Okay. So
And
this is just in this
special version, the probability related version.
Okay.
And every other normal distribution maps, is a transformation of this.
All right. Okay.
And the mean is 0 and the standard deviation equals 1.
Okay.
Did you get that, Mr. Newton?
Normal. I'm definitely normal.
Hello, chaps. I'm Mr. Newton. Boom. Dr. Young and Mr. Barker have asked me to expand on what they were saying at the board. Now, we know that the standard normal distribution has a mean of 0 and a standard deviation of 1. Every time that this distribution is written down, it looks like this, with Z, squiggle, N, brackets, and then we write the mean, which is 0, and the variance, which is 1, written here as 1 squared, because that is the standard deviation squared. Double boom. Right, now, Mr. Barker was explaining how all the probabilities can be worked out from the table. Luckily, we have a handy chart to show this. Triple boom! Now, all you need is to know what value to take from the graph. For example, the probability of it being less than 1.32 would be this area here, and all we'd say is that Z equals 1.32. That would be our Z value. Make sure we remember that term, Z value. Boom, boom, boom. Now we take our Z value, 1.32, and just look at the table. Point to 1.32, point to 1.32. And the probability is just 0.9066. So we can take the value of Z, look at our chart, and read the probability that X is less than or equal to that Z value. Boom, diddy boom, boom, all booming day. Boom. So we know what a Z value is. The way we write this mathematically is to write, we are working out the probability that Z is less than little z. And this 1.32 is our little z value. Much as similarly seen in our probability distributions. Okay, so thanks to Mr. Newton's excellent explanation, we should now recognise this Z value. And all we're going to do, I'm going to show you how with a little bit of sketching and the tables, it's super simple to work out any of these probabilities. So for part A, it's asking us for the probability that Z is less than 1.52. So I'm going to draw my sketch as I always would. I know the mean is 0, so 1.52 is going to be somewhere over here. So 1.52. So the probability it's less than 1.52, I'm trying to work out this bit here. And all I'm going to do is I'm going to put that into my table, and I'm going to say, well, where is 1.52? It's up here. 1.52, read off straight away, the probability is 0.9357. So I can just write that down. The probability is 0.9357. Simples. Right, for part B, it asks me for the probability that Z is greater than 2.60. Now this is one of the reasons why we draw sketches, because this is where it first starts to get a little bit tricky, but not too tricky. If I draw my sketch, I've got a mean of 0, and I know 2.60 will be to the left, and it wants greater, so it wants this value here. Now, the key thing is that the probability in the formula booklet gives us the probability of Z being less than a value. But we know that all probabilities sum to 1, so the probability of getting the black bit, well, that equals 1 minus this probability here. If I take this probability away from 1, what I'm left with is the black bit. So it's the probability of Z being less than 2.60. Alright, so 1 minus the probability of Z being less than 2.60. So I can look that up. That's 1 minus, and I look it up in my tables again. I look for 2.60, which is all the way up here, 0.9953. So it's 1 minus 0.9953, which obviously is 0.0047. So that's the probability of Z being greater than 2.6. Not very likely. Okay, the third one, part C, brings me to an interesting conundrum, because the more observant of you will already see that our tables, our chart starts at Z equaling 0, that mean. So it doesn't have any nice readable values for negative values of Z. So it asks me for the probability of Z being less than minus 0.75. Alright, now if I draw my sketch, I've got 0. Well, not minus, so it'll be on the left hand side. So somewhere down here I've got minus 0.75, and it wants the probability that Z is less than that, so this area here. Alright, now the way I work this out with negative values is to use the fact that the normal distribution is symmetrical, and it's symmetrical about 0. So that area there, which represents the probability, is identical to this area here. I've just reflected it about the mean. So that area is identical to that area, and I can look up that in my tables. Now obviously, using my shading, this is equal to the probability that Z is greater than 0.75. That's positive 0.75. But thankfully, we've seen in the last example how to deal with greater than sign. All that really means is 1 minus the probability of Z being less than 0.75. Alright, again I bring in my table, I look up 0.75, I get my probability of 0.7734, so it's 1 minus the probability, 1 minus 0.7734, which equals 0.2266. So that's the probability that Z is less than minus 0.75, and also the probability that Z is greater than 0.75. Beautiful. Alright, and the final one. This is the most complicated and definitely worth getting your diagrams ready for. So, in part D, it asks me the probability that Z is between minus 1.18, so bigger than minus 1.18, and less than 1.43. So, looking at that as a sketch, well, it'd look something like this. So we've got our mean of 0, and it's between minus 1.18 and 1.43, this area here. Okay, now to work that out, I'm going to split that up, because that equals the probability that Z is between minus 1.18 and 0, plus the probability that Z is between 0 and 1.43. Okay, so I've split it into the two halves. I'm looking at this part on the left, and then I'm looking at this part on the right. So I might even do a little sketch of that situation myself. So if I was to bring this in here, I split that up, I've got the probability that Z is between minus 1.18 and 0. So as a sketch that would look like this part here, plus the probability of Z being between 0 and 1.43. So do that as a sketch. That's this part here. Okay, and the way I would work that out, well, for this one it's negative, so we're going to have to reflect it. So I'm looking at 1.18, and I'm looking at this bit symmetrically. So that is the probability that Z is less than 1.18. Take away the probability that z is less than 0. So I'm doing all of that, take away that, to leave me with that part, the red part. So that's how I would work out the left hand side. And then the right hand side, the probability that z is between 0 and 1.43, well similarly that's the probability that z is less than 1.43. That gives me everything less than 1.43. Take away the probability that z is less than 0. So take away that bit, leaving me with the part I want, that z is between 0 and 1.43. So I'm going to go back to my tables for that. So the probability that z is less than 1.18 is 0.8810, looking that up in my table. And I'm going to take away from that the probability that z is less than 0. Well, you could look that up if you want, but you should recognise that if it's halfway, it's going to be 0.5, so minus 0.5. And plus to that, well, the probability that z is less than 1.43 is 0.9 something or other. 0.9236 plus 0.9236 minus z is less than 0, so 0.5. So when I crunch those numbers, that's got 0.3810 plus 0.4236, which gives me a final answer of 0.8046. Now, you might not need all these diagrams once you get practiced at it, but you'd certainly always draw at least one, and if you're in doubt, sketch it out. What do you think to that, Mr. Newton?
I'm normal, right? Yeah?
Right, as Mr. Barker said, when doing these questions, it's vital to draw a picture. Now, in these examples we're going to look at, we're going to involve some working backwards and also using an alternative version of the tables. So let's have a look at part A. We want the probability that z is less than little a. So if we draw a picture, then we notice that the probability of z being less than a is 0.7611. So that's over 0.5. So if here is 0 in the middle, so for it to be z being less than a must be this side of the mean 0 because it's bigger than 0.5. So this would be our area 0.7611, and so we're looking for this value a that gives that probability. Well, what we do is we go to our tables and we look up 0.7611, this time from the probability side. And if you do that, you should see that 0.7611 comes from a z value of 0.71. And so therefore, from the tables, a equals 0.71. Right, let's have a look at part B then. So this time we want the probability that z is bigger than a. And so when we draw our picture, we've got the probability that z is bigger than a is as small as 0.01. And so if you think about it, that's a really small probability. So the probability that we're bigger than this is really, really small. And so it's going to be up this end of the picture. Okay, so this probability here is 0.01. Now, this is a really nice probability. Whenever you get nice probabilities, you want to turn over the booklet and look at the nice version of the tables. Now, there's one extra thing we need to know about the nice version of the tables. They give the probability that z is bigger than the value given, which is the opposite to what it does in the normal version of the tables. So, we want the probability that z is bigger than a being 0.01. So we go to 0.01 in our tables and we find that our z value must be 2.3263. So A must be 2.3263. And it doesn't matter that this was bigger than it, because that's what these tables give us. They give us the probability that Z is bigger than the value given here. Okay? Right, let's have a look at part C then. So, part C, we want the probability that Z is bigger than A is 0.0287. So that is again a probability that's smaller than 0.5. So if we want Z to be bigger than that, A is going to be here, and this is going to be 0.0287. Okay, that picture's right because this isn't bigger than 0.5. It's not over this side. Now, this isn't a very nice value. So we want to use this version of the tables. But remember, our normal version of the tables tells us the probability that Z is less than this value. But we want the probability it's bigger than. So if this has an area of 0.0287, we know that this has an area of 1 minus that. Which comes out as 0.9713. So what we're looking for in the tables is 0.9713, because this tells us the probability that Z is less than A. So if we look up 0.9713, we get 1.9. So therefore A must be 1.90, because we're looking up the 0.9713. Right, one final example. This time we're looking up the probability that Z is less than A is 0.0170. So, again we've got something less than 0.5, so when we draw our picture, we want Z to be less than that, being this really small probability. So we want Z to be less than it, something small, so we're down there. So this is 0.0170. Well, normally we would go to our tables and look up which value gives us a probability of 0.0170. But if we try that in the tables, the smallest probability is 0.5. So that seems like a bit of a problem. We can't look up a probability of 0.0170. But there's a reason why the probabilities stop at 0.5, or the values only start at 0. And that's because of the symmetry of the normal distribution. So if we know that the probability of Z being less than A is 0.0170, what we could look for using the symmetry is the value up here. And this would be minus A, the negative version of this. Now, it's pretty clear that A is going to be a negative value and minus A is going to be a positive value, but you get the idea. Whatever this is the negative of it. Okay? So we want to actually find what this value is, and then we can take the negative to work out what A is. Well, how are we going to do this? Well, we can't look this up in the table because it's not a very nice probability. We can't use our forward tables. So we're going to have to work out the probability that Z is less than minus A. So that is all of this area here, including this bit. Okay? So to do that, we do 1 minus 0.0170, which equals 0.9830. So that's the probability that Z is less than minus A, so all of this bit. And then we look that up in the tables. So 0.9830 gives us a value of 2.12. So this value minus A must equal 2.12. So therefore the thing we're interested in, A, probability that Z is less than this, must be minus 2.12. And we're done.
I'm normal, right?
Definitely not. Bill, do something exciting.
What, to go in the outtakes?
Yeah.
Okay.
There's no practice your Mr. Newton. Hello, Mr. Newton. Okay.
Nice one.
Should we just keep rolling? Should we try it, or do we need to script it first?
No, let's go for it.
Okay.
Nice one.
Hello, I'm Mr. Newton. Boom. Dr. Young.
Sorry.
Okay, so, I mean, we know that the normal distribution looks a bit like that.
Okay, yeah.
Yeah? I can't live with myself. That's the worst story I've done in my whole life. I was like, I can't do this, sorry. Hello, Dr. Young.
Hello.
What are we doing this week? Are you going to say your bit about...
I'd forgotten.
I was like, should we practice this? If I just wait, Doc will say it. Unbelievable!
Should we just cut that bit in?
Okay, cut that in. Alright, chaps, I'm Mr. Newton. Boom. That was good. Alright, that's it. That's it, no more. How long's outtakes going to be?